So one of the examples that sort of really shows that we're doing the right thing here at LSU and through the CCT comes from the fact that the National Science Foundation, through a very competitive program, has funded a project to help us teach graduate students in an interdisciplinary mode of how to model fluids. And this program that the National Science Foundation has is called the IGERT, the Interdisciplinary Graduate Education and Research Traineeship Program. And our project was funded to create an interdisciplinary program linked through the CCT in the Coast to Cosmos focus area, where we train graduate students from many different disciplines in how to model fluid flows on high-performance computers in a lot of different environments. And so we now have 10 students in that graduate program, and they're from 10 different disciplines on the campus. One of the elements of the design of this interdisciplinary program, and in fact it's a strong element that the National Science Foundation review teams appreciated, is that a student who gets trained in modeling flows in just one discipline doesn't necessarily appreciate that they can contribute their expertise to a lot of different areas. So one of the things we really accomplished through this IGERT program is to show the students, to have them essentially live together as graduate students and share experiences on their modeling techniques and come to appreciate that they're doing fundamentally very similar things. And they can talk across disciplines with one another and can share ideas all the way from what extra terms have you put in this mathematical equation to do your problem, and why don't we have those terms in our in the work we do, to, well, how do you take those mathematical equations and teach the computer to solve them efficiently? So the students have to learn the computational science aspects that are just independent of discipline. How do you program the mathematical equations on massively parallel computers? And so they are sharing those ideas with one another. And some of the students actually, their expertise is in scientific visualization. And they're there to help understand how you model fluid flows, or generally three-dimensional complex configurations. How do you visualize those results? And they teach the other students how to make use of the most modern techniques in that area.